Welcome to our tutorial on deep learning for computer vision. In this video, we'll explore how this transformative technology is revolutionizing the way machines see and interpret the world. Gain valuable insights into the power of deep learning and its impact on various computer vision tasks. Let's get started. Before diving into the details, let's first understand what deep learning is. Deep learning is a subset of machine learning, distinguished by using neural networks with many layers designed to mimic the human brain. These networks learn from vast amounts of data to recognize patterns and make decisions. The key components of a deep learning model are neural networks, layers, and activation functions. Neural networks are structured as layers of interconnected nodes, with each layer processing its input and passing the result to the next layer. The process starts with an input layer that receives raw data, which is then processed through hidden layers. Each node in the hidden layers applies a mathematical transformation based on weights and biases, helping the network learn complex patterns. The activation function determines whether a neuron should be activated, adding nonlinearity to the model. Finally, the processed data reaches the output layer, where a prediction or decision is made. The beauty of deep learning lies in its ability to continuously improve through learning. The more layers, the better the performance, allowing deep networks to achieve high accuracy in various tasks. Now that we've covered the basics, let's explore how deep learning applies to computer vision. Stay tuned. Welcome back. Now that we've covered the fundamentals of deep learning, it's time to dive into computer vision. Computer vision empowers computers to interpret and make decisions based on visual data, much like humans do with our eyes. It involves tasks such as image classification, object detection, and segmentation. Image classification involves assigning an image to a predefined category, like classifying a picture of a dog as a dog. Object detection goes a step further, identifying objects in an image and pinpointing their locations, such as a self-driving car recognizing pedestrians and road signs. Image segmentation divides an image into regions, categorizing each pixel, which is useful in medical imaging to identify tumors in MRI scans. Deep learning models process and learn from visual data, achieving remarkable accuracy in analyzing and interpreting images. As we move forward, you'll see how deep learning complements computer vision, enhancing these tasks' efficiency and accuracy. Let's continue our journey and explore how deep learning enhances these capabilities in the next segment. Deep learning has revolutionized computer vision. With models like convolutional neural networks, CNNs, excelling at recognizing patterns in visual data. These networks are ideal for tasks such as image classification and object detection. Recurrent neural networks, RNNs, add sophistication by handling sequential data, improving predictions in complex tasks. Generative adversarial networks, GANs, push boundaries by creating new, realistic images from scratch. The integration of these models with computer vision has unlocked possibilities like autonomous vehicles predicting object movements or medical imaging systems diagnosing diseases with high accuracy. Deep learning models process large volumes of data more quickly and accurately than traditional methods, which is crucial in applications like video surveillance. These models are highly flexible, adapting to new data types without extensive reprogramming. They achieve high accuracy even with complex real-world data, such as recognizing faces in crowded scenes or detecting subtle manufacturing anomalies. As we move forward, you'll see these models in practical scenarios, demonstrating their transformative potential. Next, we'll dive into an example of image classification, showcasing the step-by-step process of building a deep learning model to classify images of animals. Let's dive into an example of image classification using deep learning. We'll classify images of animals using a convolutional neural network, CNN. First, we'll discuss what image classification is and why it's important. Image classification involves categorizing images into predefined classes, crucial for applications like medical diagnosis and autonomous driving. For our project, we'll select a dataset of animal images, pre-process the data, and build a CNN tailored for image classification. The model will learn to identify patterns unique to each animal category. We'll train the CNN using the pre-processed data, allowing it to improve its accuracy with each epoch. Finally, we'll evaluate the model's performance using a separate set of test images to gauge how well it generalizes to new, unseen data. As we move forward, you'll see how object detection can further enhance computer vision capabilities. Next, we'll delve into object detection, a crucial aspect of computer vision. We'll walk through a real-world example of detecting objects in a video using a deep learning model. First, we'll introduce core concepts behind object detection, highlighting how models can recognize various objects with remarkable accuracy. Then, we'll use a pre-trained model to detect objects in a sample video. Through a step-by-step walkthrough, you'll see how to prepare your data, set up the model, and interpret the results. By the end of this segment, you'll have a practical understanding of implementing object detection in your projects. Stay tuned for more hands-on examples and insightful analysis in the upcoming sections. Finally, let's delve into image segmentation, a critical task in computer vision. We'll focus on a practical example, segmenting medical images using a deep learning model. Image segmentation partitions an image into meaningful segments, aiding in analyzing contents. This is especially valuable in the medical field, helping identify areas of interest like tumors. We'll explain each step from preparing the dataset to training the model and evaluating its performance. Our example project will demonstrate these concepts in a real-world scenario. We'll use a fine-tuned deep learning model for medical imaging, training it with annotated medical images and assessing its accuracy. By the end of this segment, you'll understand how image segmentation works and its effective applications. The transformative impact of deep learning on various industries shows immense potential for the future. Deep learning has transformed computer vision, impacting numerous industries. In healthcare, it aids in early diagnosis and treatment planning with higher accuracy in medical imaging. The automotive sector benefits through advanced driver assistance systems, enhancing safety and autonomy. In security, deep learning bolsters facial recognition and surveillance, improving public safety. Further advancements in deep learning hold immense potential, although challenges like data privacy, ethical concerns, and the need for vast computational resources persist. Industries must navigate these complexities as they leverage deep learning for innovation. Continuous research, ethical guidelines, and technological improvements are necessary. The journey ahead is complex but promising, bringing us closer to a future where intelligent vision systems enhance our lives. Join us in this exciting endeavor. Remember, every step we take today shapes the technological landscape of tomorrow. Active engagement and collaborative efforts will shape our shared future. Let's answer some common questions about deep learning and computer vision. From neural networks to real-world applications, we cover it all. Leave your questions in the comments below. As we move forward, you'll see how impactful this technology is and what the future holds. Ready to dive deeper? Stay tuned. Thank you for watching our tutorial on deep learning for computer vision. We hope you found it informative. To stay updated with more content, subscribe to our channel, like this video, and share it. Keep exploring, keep learning, and let's shape the future of technology together.